I'm Sumana Sharma and I am a Sir Henry Wellcome Postdoctoral Fellow in MRC WIM in University of Oxford, working together with Professor Simon Davis. I am trying to understand how inhibitory receptors, which are these special molecules on the surface of T cells, function by using CRISPR-based methods. So the genome CRISPR-Cas9 screens, they come in various flavors, and the easiest way of doing this is doing essentiality screens, where you just look at whether a cell dies when a specific gene is knocked out. Whereas in terms of looking at immunity, we're trying to find a bit more focus on what kind of contribution each of these genes provide in signaling in an immunological context. So in terms of inhibitory signaling, we want to use genome-wide screens to understand very specifically how does the inhibitory signaling within the T cell works using this method as a tool. So the cancer dependency map, in the simplest sense, provides the list of genes that are essential for a given cell type. Now, in the simplest sense, this allows the researchers to understand what are the vulnerable genes with the model system they're working in. But what it's really good at is providing context-essential genes because of the wealth of information it has behind it. So the existence of this kind of context-essential genes can be important for researchers who are interested in specific contexts, for example, mutations, but also expression levels, CNVs, or in my sense, an immunological response. So by overlaying these other features of a cell line together with the vulnerabilities, we can really start to understand what really defines the context that you're interested in. So the cancer dependency map, as it is currently stands, is basically built on vulnerabilities, or just identifying genes that makes the cell alive or dead. And while this information is very useful, it doesn't quite provide the exact signaling pathways that the cells are using, or when we identify a gene that's essential, why is it essential in the first place? So I think building up on what we already have, it'll be important to then next look at why are certain genes essential, what role do they play mostly in the context of cellular signaling.